Match problem 3 is going to be a bit of a beast to tackle, but it's really essentially the same idea as match problem 2. We're going to find the first and second derivatives, any inflection points, and then construct a sign chart. The part that's going to be more challenging here is finding not so much the first derivative, but the second derivative. That's going to be a longer problem to evaluate. So we have a composite function, the natural log of some function. So we can take the derivative as 1 over x squared minus 2x plus 5 times the derivative of that interior function. So x squared minus 2x plus 5, so times the derivative of that function, which is going to give us 2x minus 2 over x squared minus 2x plus 5. So now we need to find the second derivative of this function, and in this case the only way to do that is to apply the quotient rule to this problem. So we're going to start off with the derivative of the function in the numerator, so the derivative of the first function times the second function minus the first function times the derivative of the second function. All of that divided by the original denominator, or the second function, squared. Oh, and that should be the derivative of the second function there. So this will become 2 times x squared minus 2x plus 5 minus 2x minus 2 times 2x minus 2, which is the derivative of that second function, will give us x squared minus 2x plus 5 squared, or just that denominator remains unchanged. So now we could distribute through. That's going to be 2x squared minus 2x minus 4x actually, plus 10 minus, expanding this out, 4x squared plus 8x, or I'm sorry, minus 8x plus 4. And then distributing that negative through, this will become minus 4x squared plus 8x minus 4. All over x squared minus 2x plus 5, that quantity squared. So combining like terms, in the numerator will give us negative 2x squared plus 4x plus 6 over x squared minus 2x plus 5, that quantity squared. So we have the second derivative, but we still need one more step in there to find the critical values, and that's going to be to factor the numerator and then set this function equal to 0. So the numerator can be factored as negative 2 times x plus 1 times x minus 3 all over x squared minus 2x plus 5, that quantity squared, and then we'll set this equal to 0, which will be true whenever x equals negative 1 or positive 3. And then again, we would just set up this sign chart and then choose some test points in between. So I'll leave that part for you to go ahead and do, since we've done that a few different times from module 7.1 and 7.2. But what you should be able to demonstrate is that between negative 1 and 3, that second derivative is going to be positive, and then on the remaining intervals, our second derivative will be negative. So we have two different points where concavity changes. It changes from negative to positive at x equals negative 1, and from positive to negative at x equals 3. So x equals -1 and x equals 3 are both inflection points.